then we can get going. So, with that, I will let Ayush introduce himself. Ayush, why don't you go and introduce yourself?
Thanks, Madhumita. Thank you so much. Um, thank you everybody for joining this session. So my name is Aayush Bajaj. I work as a data scientist in fraud and film crime department in the NatWest Group. It's for those who don't know, it's fourth largest UK bank. And a little intro about myself. I started my career as a machine learning engineer working on chatbots, text to speech systems, and deployments. Before just to add up this here, I graduated in computer science in 2020. After my stint as machine learning engineer, I switched over to data scientist, and which is where I am right now, and sort of got exposed to vast amounts of data and working on anomaly detection at scale. So yeah, pretty exciting stuff.
Great, Ayush.
Over to you, Madhumita.
Thanks, Ayush, for the nice intro. Anything that you want to share about yourself that's not on your LinkedIn profile?
Sure. I'll also talk a little about anomaly detection as well, which is my current project, and the company is focusing too extensively on this one as well. So we deal in vast amounts of data, and particularly in anti-money laundering. So it involves sort of it involves transaction analysis, studying onboarding profiles, studying risk appetite of the customer, and the biggest challenge in working in this industry is sort of in anomaly detection industries. There is no set profile for anomalies, which I think is true for a lot of industries that apply anomaly detection. So we used to say in this that we have to evolve as the bad guys are evolving. So we have to keep up with them as well. As for something that's not in my LinkedIn profile, I like to play chess quite a lot. I picked it up during lockdown as a hobby, and it got stuck since then. So, yeah, really a casual player. So please don't challenge me for a match. Although I'll be up for it. Sorry.
Oh, that sounds interesting. Chess is my favorite, but I do not know how to play. That sounds exciting. So let's dive into some of the basics in terms of
Uh-huh.
what is anomaly detection in simple terms. If we have to explain to users who are not aware of what is anomaly detection.
Okay, sure. So, Madhumita, it can be anything that is out of the ordinary. So, sure, I mean, defining the ordinary is highly subjective, but any event that raises eyebrows or makes you think, like, what the hell happened, is an anomaly. So, you notice anomaly. You can notice anomaly every day in your life. This can be unexpected traffic to your website, a sudden surge in your favorite stock price, etc., etc. Like, if we take an example, Bengaluru received a lot of rain this year, and it was quite an anomaly because I was reading previous year's rainfall, and this was certainly an anomaly. So we notice anomaly at probably every day, but we don't term it as anomaly, but yeah, it is an anomaly. So yeah, it can be as small as unexpected traffic or as Bengaluru floods. So
Great. And in terms of when we talk about anomaly is something unusual, right?
mm-hmm.
So I think business performance space or system performance management, um, I'm sure like unlocking or finding these anomalies are super
Mm-hmm.
useful. You can you share some like industry wide examples that are very common for anomaly
Mm-hmm.
detection and definitely like without anomaly detection they can't survive, so if you can touch base on some of the examples and which industries are finding it extremely useful.
Sure, for sure. So I will be biased towards the financial sector. So I can certainly talk about anti-money laundering and how it has transformed how we see and find potential money launderers. So it sort of the core is anomaly detection, right? It has made businesses, financial institutions more compliant with the risks their customer possesses, and sort of essentially makes banking and finance sectors safer for wider audience and wider customers. BFSIs can be a really good example on how anomaly detection has been applied substantially. For example, I mean, we can take a lot of examples: credit card fraud detection, loan delinquency problems. These are very common problems that are available on Kaggle as well. Loan delinquency, insurance fraud, many use cases that and companies in this sector use extensively to detect outliers. There are a lot of Kaggle competitions and analytics video competitions that I've been in that caters to this anomaly detection space, and the some of the solutions were very advanced. So yeah, I think BFSI can be a good example of how businesses are using anomaly detection.
That's great to know. I have a question, follow-up question. I know fintech is
Yeah.
extremely will be benefited something anomaly
Mm-hmm.
detection and that too in transactions and stuff like that. I know
Mm-hmm.
that anomaly detection needs a lot of data to
Mm-hmm.
find the right anomaly. So most of the use cases, as per my knowledge, is offline in fintech space.
Mm-hmm.
However, real time is also super useful, especially for fintech and detecting anomalies in real time.
Mm-hmm.
Have you come across any solutions that would be more impactful to catch real time anomalies?
So I think there are a lot of solutions that cater to streaming data for anomalies, but I think a lot of anomaly detection solutions that we see right now are all passive. So we use historic data to identify and profile what the anomalies look like and be wary of the future. And if we see a particular datum in the future, we can flag it as anomaly. But the problem with I see the problem with streaming data and its application of anomaly detection on streaming data is there are a lot of changing trends in consumer behavior as well as how consumer utilize the service. So with for example, if something is an anomaly a year ago, it may not be anomaly right now because everything is changing so rapidly. We have data drifts, we have model drifts. So not a single piece of machine learning model can work on a streaming environment, I think. But I can be wrong in this. But I know there are a lot of passive examples, but not a lot of streaming that's good and detects anomalies in a very efficient manner. So yeah.
So having some streaming solution would be definitely helpful. Is that what we can summarize from this discussion? But we don't have great solutions out there.
For sure. I think streaming, anomaly detection on streaming can be a good next step towards any anomaly detection solution because it can be an evolution to what we use right now. Everything I've seen is passive. We use historical data a lot on a lot of industries that I have seen in. So yeah, I think a streaming anomaly detection solution would be a good next step.
And apart from fintech, which other industries would be helpful with streaming analytics? Sorry, streaming anomaly detection.
Well, I think e-commerce and SEO can help quite a lot. I think these two come on top of my head as examples. So, e-commerce websites can utilize streaming anomaly detection to sort of cater to fraud. This can also be done in fintech as well, but I think e-commerce can be a larger space to use it. Apart from this, I think SEO would be a good example. Tracking your clicks, click-through rate, and everything, and traffic on your website can be a good example of um, streaming anomaly detection. So I think yeah, there can be other, but I think this two comes to my mind first.
Great. To summarize, then, this is what we are observing in terms of trends. Definitely, fintech, e commerce, SEO space where we need anomaly detection, that too, streaming anomaly detection will be
Mm-hmm.
extremely useful. Passive anomaly detection, many solutions out there and people are doing
Yeah,
that. But
correct.
streaming anomaly detection is something nobody has proven their value yet. So I think that's
That's a
a
challenge, isn't it? It poses a lot of challenge in streaming as well because you have to be wary of your data distribution changes and model drifts. You can't be just applying a single model to it and just wait and see how it changes. So you have to be wary of the future and how data might change and customer consumer trends might change. So that's also is a huge factor. I think that's probably the biggest roadblock in streaming anomaly detection.
You're saying that more than the anomaly detection solution in general in streaming, the main challenge is about data preparation and how to maintain the data quality so that streaming anomaly detection happens accurately. Is that what you're trying to say?
I think that's a technical summary that you gave, a data flow and everything. I think that can be I think there are solutions that exist right now for this, but I'm more talking about the concepts behind how businesses can use streaming anomaly detection. So just thinking about how conceptually can be a roadblock for this use case
Oh, that's a great point you
because
brought in. I
yeah.
think what you're trying to say is like definitely technical challenges uh, exist, but I think conceptually businesses are not yet there or comfortable adopting streaming.
Yes, I think yes. That would be a good summary. Yes.
That's a good point. Have you ever given a thought about it in terms of how to overcome this challenge? Is it the data literacy that businesses have, and making them aware in terms of how streaming analytics going to add value? Sorry, streaming anomaly detection is going to add a lot of value to them.
Uh, I can see it from a lens of a fintech space because I work in fintech. The thing is, there isn't a single way we detect anomalies. So personally, I've been in multiple anomaly detection projects, and the thing I've noticed is all are anomaly detection projects, but the way we approach is different, and how we utilize data and what data is being utilized is different. So if we can sort of subjectivize the problem and build our data around how we understand anomaly is in our business, then I think streaming anomaly detection can be a solution because our data would be fixed and our models and whatever we apply would be fixed. Then I think any streaming data would go inside the model and give us if the particular uh, datum is an anomaly or not. But I think it boils down to how we select our features and how we select our data.
Hmm. That's a good point. I see a few folks are listening to our discussion. I want this session to be interactive. So, any of you are interested to chime in or have a question or share your perspective or viewpoint, raise your hand and I'll invite you to the stage and you can unmute yourself and ask your question or share your perspective. Okay, I do not see any raised hands, so I'll move forward with my next question. I think as we discussed in terms of the challenges which industry um, is kind of finding it very useful in terms of anomaly detection, especially driving business performance. And in addition, we also spoke about what is the untapped area which might be very valuable to businesses, but nobody has a great solution for it. One, and then changing the perspective of business owners who are unaware how streaming anomaly detection can be powerful. Now, this can be a next. Our next question falls right in place as we think about the future. As the anomaly detection space is evolving, how does it look like? Have you done any research or thinking on this line, or have you come across? How do you see this going for, like, looking at future trend, how it's going to evolve?
I think it has come a long way in terms of algorithms, the number of tools we have at our disposal. Sure, I'm still, young in my career, but algorithms have been in for like ages. Like, for example, a simple method of finding anomalies is an STL decomposition method, which dates back to 1990. We still use it quite a lot in this day and age too. And now we have visually easy to use tools that can cater to a larger audience with or without a technical background. I saw Third Eye from Star Trek in action. I think the evolution is really going towards fast, easy to use, low or no code visual tools that can also help us in explainability of models and creating reports and everything. So a large part of analysis goes into how we report something or how we present something, and also how we explain our models. So I think um, with visually appealing tools that that can be that has a plug and play sort of a model. So we can integrate our data into it and apply models to it and create reports from it. So I think that is, I think, the way going forward.
Uh, thanks for bringing up Star Trek Third Eye. Yes, being part of Star Trek, I've been part of the evolution of Third Eye also at
Mm-hmm.
LinkedIn and here. Totally, I can echo what you just said, how it's evolving. I think as for data trends also, the main part is like how low code, no code experience plus how we can marry the business use case with the technical
Mm-hmm.
challenges and remove that friction between the two and reduce the
Yeah.
time to value. I think that is key, and storytelling is very important as well. Like if something went wrong,
Yeah.
I think everybody is interested in knowing why something went wrong, and all of this happening in real time is the way to go for. So certainly agree and echo with you what you said, and thanks for bringing it up. Do you
Mm-hmm.
are you aware of any other products or solutions out there falling into the same bucket which are ahead of the game and trying to march towards the future evolution?
Well, I haven't stumbled upon any more tools that give the same set of features as Third Eye, but I think we're going to be seeing a lot more companies and tools that will be coming up with the similar solutions. I think because this is sort of the way going forward, because it would be much more easier for data scientists like me and a lot of people, a lot of analysts to um, just focus on the business problem at hand and leave the heavy lifting to tools like Third Eye. So I think, yeah, that would be a great addition.
Great. And what's your opinion about? I know, like Third Eye gives a lot of flexibility. You can plug in
Mm.
any model, like including statistical detection model or ML models as well. In
Mhm.
your opinion, which models are performing well in terms of catching anomaly detection?
Uh, well, I think there isn't one algorithm that I can point out. It's not like we know that this algorithm will perform well, because you have to understand that you you are a slave of the data, because what data you have, your data quality, and what features you have, whether they are nominal, ordinal, categorical, numerical, and what sort of business problem are you solving in terms of anomaly detection as well. There can be many. So I think it all boils down to how your experience with the data is, how your experience with the problem is, and how you understand the stakeholders' point of view as well. Um, I um, I think I've applied a simple STL decomposition for anomaly detection as well that has worked very well on a particular data, and I've seen a lot of deep learning algorithms as well that can be a hit or a miss as well. So it isn't like a normal vanilla algorithms cannot work, and only deep learning algorithms work, but it all boils down to how you have transformed your data in a way and how you understand your business problem well. Um, there, there are a few algorithms I can talk about which I use on day-to-day basis, like STL decomposition, Z-score algorithm, isolation forest, and autoencoders. So, and on a lot of ensemble and gradient boosting methods. So, I think it as a data scientist as well, you have to be wary of how you implement algorithms to a data rather than just plugging it an algorithm on any data without looking at it. So understanding variance and everything, key statistical methods, it's key to before you apply any ML model.
It's a great point you brought up. Yes, I think first thing is what's the problem you're trying to solve, use
Correct.
case, and then thinking and doing the data mining to understand what kind of model will fit in better, and then applying the right model to it. And I've seen historically, if we are monitoring KPIs instead of data, like there are two ways you can monitor detect anomalies. So you might be
Hmm.
mining data to find some interesting insights. As an example,
Yeah.
I'm mining data to find what are the interesting, if I'm looking at say address data, and I'm mining the
Hmm.
data and finding what are the poor quality data in the addresses, or what are the addresses that looks like more often than before, and
Hmm.
this is one example of mining the data and identifying anomaly detection. There's another
Hmm.
way to look at anomaly detection is what we are talking right now is the business performance or system performance. It boils down to KPIs or
Right.
metrics. And when you're trying
Right.
to monitor metrics, based on my experience, I've seen like statistical model perform better as compared to
Hmm.
ML model, because ML model
Right.
comes with a lot of pain in terms of training the
Right.
data, and a lot of effort
Hmm.
goes in. But in statistical detection, using like KPI monitoring could be a lot more easier. So what's your opinion on that front?
I think for sure I'll second that because you can sort of implement a lot of metrics. So the thing is, before embarking on a journey for any data science problem or anomaly detection problem, you have to sit with the business, sit with the stakeholders, and sort of on paper you have to define what you're trying to do and where you have to go because I've seen a lot of problems where there is no end, there is no goal, but you have to address this problem first on how you're going to solve it and how far you're going to solve it. So this was on to as you said KPIs and metrics. You have to define what's the end goal for you and then start building from stage one. So yeah, I think that's a great point. You can and of course a lot of anomaly detection as well as data science problems can be solved using simple statistical methods rather than building a big ML models on them. And with statistical method, there's the ease of explainability as well. You have more hold towards your data flow, how the predictions are being made. So yeah, I totally second that.
Great. We have quite a few audience. Again, I will just mention that this is an interactive session. So if you have any viewpoint or question or perspective that you would like to share, raise your hand and I will invite you to the stage. And you can ask your question or share your perspective or experience, and try to make this interactive. So let's see if any raised hands for a second. Otherwise, I'll move on to my next question. Okay, I don't see any raised hands. Let's see. Let's move on to the next question.
Mm-hmm.
So, great thing. Like, I mean, to summarize, we spoke about what is anomaly detection, how it is helping managing business performances. We touched base on some of the examples and the popular industry-wide use cases that are right now getting benefited with anomaly detection. And as we are
Mm-hmm.
thinking the future, how it's evolving, we spoke about that. And now let's discuss what are some of the common challenges that are still coming on the way to use
Mm-hmm.
anomaly detection to manage business performance or metrics or KPIs. And what is your role as a data scientist in that? And as a data scientist, what are the challenges do you commonly face?
Well, I think that's a very good question, and I think and a lot of data scientists would agree with me here that a large part goes into solving data issues, and since there is no single source of data that you can just query and run your algorithms on, with respect to if you're working in a large organization and you have data across many tables, and you have to really work on data collection and understanding the business problem first, because there can be no universal anomaly detection that can do the trick, right? So you have to spend time with the stakeholders, like I said in previously as well. You have to spend time with the stakeholders and the business to identify and study what you're trying to do, and the features you might need for a successful implementation of the analysis. I mean, it's like you have to define the limits or how far you want to take this. Like I said similarly before, you have to define what your goal is and where you have to end this analysis before actually starting or embarking on the journey. I think the most common challenges are, I'd say, data related. I am gonna repeat myself again and again, but it's still data related, because you, in a large organization or anywhere for that matter, the data you might need will have to be transformed and rewired and made it in a way that you imagine. And so, as a data scientist, I always, when a problem comes in my way, I start to think about how I can and what features I might need. So. And some golden source table might not contain the information that I want in a way that I want. So a lot of querying goes into it to make it into a transform table that my models will consume. Although I think it may sound easy but in my opinion, the most important part of the analysis is this: how you build your data, how you sort of get your transform table. So it's simple. I think garbage in, garbage out theory.
Yeah, that's a very good point you said, and I've seen that quite happening everywhere. And that actually takes up a lot of time. Like any time we are trying to onboard a new use case, also that I
Yeah.
mean, especially in large organization, I think that comes on the way. How did you like? How do you manage? I mean, have you come across any tools or solutions that make your life easier in terms of data transformation or modeling? Because after that obviously the storage and anomaly detection on top of it matters, and there are solutions out there which is solving, and we earlier talked about Startree Third Eye with like Startree Third Eye is built out of I mean built on top of Apache Pinot, so it takes
Mm.
all the power of Apache Pinot and makes it super easy and quick. That problem is definitely it is solving. The main
Mm.
thing is like prior to that stage, like storing the data and querying, I think that problem is quite solved. But as you said
Mm.
rightly, scientists spend a lot of time in transformation and modeling. So write data in, then you will get the most value from products like
Right.
Apache Pinot or Started Third Eye. We spoke about it earlier. So now,
Right.
which tools or solutions or any best practices that you followed that kind of expedites the data transformation and modeling so that the time to value is quicker?
I think I'm going to be old school here, but I think your SQL skills sort of makes a lot of difference. If you know the business problem well, if you assume that you know where your tables are, where your databases are, and where they are kept and everything. So I think the most important aspect is here is technically your SQL skills and how you're well versed with queries and everything. That can cater and help you a lot with the transformations. Other than that, I use PySpark a lot, so I'm gonna give it to Spark as well. So if your Spark skills are good, then you'll be good to go. Apart from this, I think it's really about, one is business problem, which I think if you understand it well, and then there is your querying skills, and then there is how you've planned your analysis well on EDA, because there is no defined EDA on this, and this depends upon what your data is and what your attributes are, what your features are. So I think EDA skills, querying skills are the most important in studying the data right before you start modeling or before you apply any algorithms on it.
Great. That's a good share. I think that's helpful. So, if I had to summarize, it's first is nailing down your use case or business problem. That's
Yeah,
very, very
yeah,
important.
correct.
Second, you're saying is the mining, right? Data mining, like querying skills, which will help you to
Right.
mine the data, understand the data very well, so that you can map the data to the use case, right? And then
Right.
a third is like process the data using Spark or other like PySpark you talked
Right.
about. That's the
Right.
transformation that we are talking about, like transforming the
Right.
data.
Right.
And
And just apart from this, a good relationship with data engineers or data owners might help a lot.
yes, and the third phases actually then comes the detection, and then if you do this first three-step right, you will get the best value out of the detection step, of
I
course.
think I 100% agree with that. So once your data part and ADA part is done, you've now and you will be confident enough to apply a lot of models to it. So that is, I think, a crucial step before modeling. Modeling is also a crucial step, but I think before modeling, it has to be a clear pathway towards modeling.
Got it. And if you have done all those earlier stage right, and you have a good solution in place, because not that everyone is discovering this for the first time, but after
Mm-hmm.
that, definitely the detection solution will be very helpful.
Right. Very, very, very important.
Great. I see a few folks in the audience. Again, I wanted to mention that if you have any question or want to share your perspective, make this as an interactive session. Raise your hand and I will invite you to the stage. Okay, I don't see any raised hands, so I'll keep going in terms of the next question I have. So we quite interesting discussion, Ayush. I think we definitely got some interesting facts about how data scientists are being instrumental in terms of detecting anomalies in
Mm-hmm.
managing performance of business or system through KPIs and metrics and what comes on your way. So my next question is, let's talk about anomaly detection solution overall, in terms of
Mm-hmm.
what is I mean, we briefly touch about data quality and defining the problem statement, right?
Mm-hmm.
But what about like data patterns and finding the right detection technique, or building training or testing data sets? What are the roadblocks mostly come during this phase, and how can we quickly iterate on that and then reduce the time to onboard?
Sure, sure. I think like you said, finding the patterns in the data can be a bit challenging because with lots of data volumes coming in, we have categorical numerical features that has to be handled differently. So finding the patterns can be hard, and there are algorithms that can cater to how you find patterns, like dimensionality reduction and everything. And of course, choosing the right technique, which also comes with sort of a lot of experience in trying different algorithms. With different algorithms, I just want to say it should be logical and not just trying every algorithm out there. So like for example, if I'm on a time series forecasting model. I just don't want to apply every model that is out there. It shouldn't be just blind hit and trial. It should be an informed hit and trial. You understand the data first, and then you apply models to it. Uh, see how much variance there is in the data, and the model you are applying. See what's the appetite of that model, and whereabouts of different hyperparameters and stuff. So I just want to add, even after you've chosen the algorithm, you've got to train and optimize the hyperparameters, and it also comes at a serious cost, as you just can't grid search your way out of in a large data set. So these all come in tandem. Your training and your hyperparameter tuning. So finding the optimal tuning technique can also prove to be a headache in my experience as well. And in further that, I think testing and evaluation, and that probably the most integral step, since you have to be wary about change in distributions among train and test sets. There was an interesting thing I was reading about a couple of days ago about adversarial validation, which is a great technique to for testing and evaluation. People can just go into it afterwards. So I think it can be a great way to distinguish between data distributions in train and test sets. Um, Finally, add this is explainability of your model and how every feature contributes feature importances. When working with different your businesses, your stakeholders, you have to be thorough on how do you explain your model, sort of like how your model does what it does, because we all know ML algorithms can be sort of a bit of a black box in decision making, because we sometimes don't really know what's happening inside of them. And these explainability techniques, like I can go through a lot, UMAP, it's Shapley values and everything, are our best bet for the explainability of models. Although they are probabilistic in nature, I'd say, but it gives a good idea on how the ML model is behaving. And I'd say the knowledge gain can be used further to sort of it can be a feedback loop, isn't it? How our models is behaving, what the explainability is like, and further furnish our knowledge about how the model is behaving, and tweak the model and tweak the data in a way that we want results of.
Yeah, very well said. I think what stuck on me it was the feedback loop. I think that is key,
Yeah.
and obviously testing and validation. And technically, solving for testing and validation, there are multiple solutions out there. But what's
Yeah.
important, I guess, end of it, how would you close the feedback loop from the end
Yeah.
users, right, who are ultimately impacted? I think that's
Yeah.
a way to go for. And yeah, definitely, that's a good point you brought it up. And in fact, in using, like, I mean, we were talking about third eye earlier, and it does that feedback loop very well today, and it does take into consideration the end user feedback. One challenge I do see with collecting feedback and closing the feedback loop, the end users also have to put a lot of effort in mentioning that. Have you encountered any challenges in that area and any solutions that worked to solve that specific problem, which is
Well,
collecting feedback loop or
I
closing
haven't
loop?
been consumer facing, but I want to say this feedback loop thing is challenging, because then again I'm going to press on my point you mentioned before, that it has to be defined very clearly where you have to stop, because feedback loop can be an infinite loop as well, and how you keep on improving your models, and it can be improved infinitely. So you have to define where you want to stop and what sort of highly congruates with your business problem. If you solve that business problem, you have to stop and close the feedback loop. So I think of it in that way.
Yeah, that's a great point. I think defining the end goal or end state
Right.
is extremely valuable. Okay, I am almost towards my last questions, last but one. But before that, I'll see if anybody in audience have question or want to share their perspective. Okay, I do not see a raised hand, so I'll move forward with my last but one question. So we did talk about in roadblocks, and we talked about
Mm-hmm.
interesting patterns. We talked about what is anomaly detection, what solutions out there. I think what I'm interested in knowing, and since you are working in this field day in out as a user
Mm-hmm.
of the solution, how would you define a perfect anomaly detection? If you were to ask, like, I want a software that is doing a great job of anomaly detection, what that software will look like to you?
Well, as for this anomaly detection, I don't think there will be one perfect solution, and will be for a long time. Data is the foremost element that makes or breaks any data science solution, and hence, as long as there are changing trends among customers and businesses, there would be a change in data distribution and hence your models. So I think a lot of solutions that exist cater to a problem where we are tying everything up together and solving the problem at hand rather than going into too much technical details and getting stuck there. Because I've seen myself working and a lot of my friends in the space working, we get stuck on technical details too much, and we forgot our main goal or main perspective should be how to solve the business problem, and not it shouldn't be looked at as a technical problem. Technicalities are just a way to solve it. So I think that's quite key, and I think a lot of tools like Third Eye as well are trying to solve and bridging the gap between this. So keeping the heavyweight covered, people like me and people like a lot of analysts can just utilize that tool to finding the right solution for a business problem.
Great summary, Ayush, and thanks for sharing the perfect or the ideal solution that you would hope for as a data scientist to solve anomaly detection. So let's. I think that's all I had in terms of questions. I'll do a last call if audience has any question, or I will just wrap up with some summary insights and key takeaways. Okay, I do not see any raised hands. So, in order to summarize the overall, like what we discussed today and what are the key insights we came across and the closer overall or wrapping up, and I use chime in if I missed anything. So, I'll just try to summarize the best possible way. So, those users who do not know anomaly detection, what it is, in simple terms, anomaly detection is something that's not very obvious or ordinary, and which you find very different than the rest, and that's what called anomaly or the outlier. And it's very important as businesses are growing, data is growing, and nobody is sitting and watching them all through the day or all the time. And there are blind spots that without uncovering those blind spots in a timely fashion, it could have adverse effect, whether it's for your business or your system. And having an anomaly detection solution is going to be very very helpful in these cases. And based on my discussion with Ayush, it seems like streaming anomaly detection is not very well solved, that space. If we go after solving that space or addressing that space, could be very valuable to many businesses. However, there's another challenge that many of the business owners do not know if this is valuable to them. So there is a data literacy gap out there we need to close, and then see how this can be valuable. Some of us are able to see this, and how we can like keep marching towards that, like streaming anomaly detection is key.
That's a very valid point. Data literacy is a very valid point.
Yeah. And besides that, I think industries we talked about which are finding very useful using anomaly detection solution are like fintech for sure, and then e-commerce is another one. Am I missing on anything else, Ayush, or you have anything to add?
No, I think you got it all covered. Just one thing, just want to add in terms of from the perspective of a data scientist, to try to look at how sort of your business problem and your data correlates. So try and finding the right patterns in the data, and I'd say look at a lot of data, so you get an idea on how to approach things in a way that solves the business problem rather than just looking into the solution first. Look at the problem first.
Yeah, very valid. And then we talked about, I mean, after marrying the problem with the solution, I think that's very, very important. And then you also mentioned that data mining and transformation plays a big role in terms of time to value. I mean, time to value in terms of uncovering the data blind spot through anomaly detection. And we also talked about like the common challenges as a data scientist you face, and how you're trying to address them, and there are no best solution out there. So focus on primarily the problem statement, and then basically how quickly you can move through identifying data patterns and then working towards the detection solution. And we did talk about star tree third eye and how star tree third eye is helping, and it's one of the advanced tool, Ayush, you mentioned, and thanks for saying that, which is evolving in the right direction, and we probably want to see more of that. And then we talked about the perfect solution would look like. Anything else you wanted to cover, or we can wrap it up?
Just want to call this out. I'm a huge fan of Apache Pino and what it does and how it does it. So I think it's probably a technical marvel in terms of streaming and how businesses utilize Pino in anomaly detection as well as other data science problem would be a key to understand how data science can be solved in a streaming environment rather than in a passive environment. So I think yeah, just want to give a shout out to Apache Pino.
Oh, yeah. Thanks for saying that, plus 100 to that for sure. And start. In fact, Third Eye is built on top of Pinot, taking all the goodness of Pinot. So that's a blessing. So with that, I think we are end of the session. I just wanted to see if audience has any question, or anybody would like to share any perspective. You can raise your hand and I can invite you to the stage. If not, then we are going to wrap up. So let me wait for a second. Okay, looks like nobody has questions. So, going to wrap up. Before I wrap up, if anybody wants to talk to us or chat with us, I think I use your handle is LinkedIn handle. People can reach out to you on LinkedIn if they have questions, follow up questions.
Sure, for sure.
Sure. And same as me, I'm also available in LinkedIn, and you can, if you have follow-up questions, you can reach out and DM me. I'm recording this session, so I will share the recordings later, and I also publish a newsletter on a monthly basis. So the summary of this session will be also in the newsletter, so please look out for that. And thanks a lot for listening to us and making this session interactive. And special thanks to Ayush. First, I mean, sharing very good insights. Though you're early in your career, you have learned a lot. Super impressed with your insights, and also talking about a lot of interesting things in terms of the future of anomaly detection. And it was great to have you on this call. And yeah, and thanks for being the champion for talking about Startree Third Eye and Apache Pino.
Thank you so much for having me. It was a really great session on talking about how the trends have been and where this anomaly detection space will be going in terms of streaming services. So I think, yeah, really informative session.
Thank you. Yeah. With this, I'm wrapping up. Thanks, everyone. Bye.
Thank you so much. Thank you. Bye
Thank
bye.
you.